So maybe the most famous theorem in mathematics is the Pythagorean theorem, which says that the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse of the right triangle. And that's not something I'm going to prove here, but I am going to use it, as the distance formula is pretty much exactly the same thing. So the Pythagorean theorem says if you have some right triangle of leg lengths a and b, hypotenuse of length c, then a squared plus b squared is equal to c squared. So we're going to keep this in mind when we're trying to find the distance between 2 points in the Cartesian plane. So imagine in the Cartesian plane, these markers are terrible. There we go. So imagine that in the Cartesian plane, we have some point here at maybe 1, 6, and we have some other point here at maybe 7, 1 or something. So you want to find the distance between these 2 points. You want to find that length. So our strategy is going to be to find sort of the legs, the lengths of the legs of these here when we construct this right triangle. And my claim is that we can find these lengths by, in this case, subtracting the y values, and in this case, subtracting the x values. So here, the distance between this point and this point is just going to be 6 minus 1, which is 5. So this is going to be 6 minus 1. And this distance is going to be 7 minus 1. Which means that this length here, if I call this point P, for instance, and this point Q, that length PQ is going to be equal to 6 minus 1 squared plus 7 minus 1 squared, which is to say a squared plus b squared is equal to c squared for any right triangle. In this case, we see that PQ then is equal to the square root of 5 squared, which is 25, plus 6 squared, which is 36. So PQ is equal to the square root of 61. 61? 61. Now, what we want to do is generalize this idea to any 2 points and sort of use this idea so that we don't have to draw this picture every single time. So the idea is, what if I have what if my point P was the point x1, y1, it was just some point in the Cartesian plane, and Q is some different point x2, y2. Then PQ squared is going to be the difference of the x values squared, x1 minus x, or x2 minus x1, I guess most textbooks say, plus y2 minus y1 squared. Now, this is going to be sort of the length of that horizontal segment that we constructed using the length PQ as the hypotenuse of the triangle, and y2 minus y1 is going to be the length of that vertical segment when we constructed that right triangle where this segment PQ was the hypotenuse of the right triangle. We take the square root of both sides and we get that this length PQ is the square root of x2 minus x1 squared plus y2 minus y1 squared. And that's where the distance formula really comes from. So it relies really heavily on the Pythagorean theorem. In fact, it really is just the Pythagorean theorem. So if you're searching for a proof of that, they're all over the place. So just type into Google proof of the Pythagorean theorem. There's tons of proofs. So let's just do an example so that the process makes sense. I'll be using this formula here. So, I guess I'll name these points something else. What if I have A is the point negative 3, 6, and B is the point 2, 5, or something? So we want to find the length AB. This is going to be the square root of the difference of the x values squared, so negative 3 minus 2 squared, plus the difference of the y values squared, 6 minus 5 squared. So, parentheses first, negative 3 minus 2 is negative 5. When I square negative 5, I get 25, plus 6 minus 5 is 1. 1 squared is 1. So 25 plus 1 is 26. This is going to be the square root of 26. And what I tell my students generally is that, look, if this thing can be simplified, we simplify it. In this case, 26 doesn't have any perfect square factors, so we're done with that. So maybe one more example. Maybe y is the point negative 3, negative 5, and z is the point negative 5, negative 8. Then the distance yz is going to be the square root of negative 3 minus negative 5 squared plus, difference of the y values this time, negative 5 minus negative 8 squared. So this negative 5 is the x value of z, and this negative 5 is the y value of y. Okay. So what do we have? Negative 3 minus negative 5, this number is 2. Negative 3 plus 5 is 2. 2 squared is 4, so I have the square root of 4 plus, here I have negative 5 plus 8 is 3. 3 squared is 9. So this is 4 plus 9. And 4 plus 9 is 13, so this is square root 13. 13 is not, does not have any perfect square factors, so it's not simplifiable. So the length between, the distance between the point y and z in this case is square root 13.